Now let's discuss a hemoglobin affinity. So the affinity of oxygen to a hemoglobin. So we're gonna look at toxicity or accumulation of carbon dioxide in the tissue and the increase or the decrease of the temperature. And we're gonna look at how the affinity, the likeness, or the attachment of an oxygen to a hemoglobin molecule, right? So that's what we're gonna look at. Hemoglobin affinity, right? So attachment of oxygen molecules to a hemoglobin molecule or at the saturation. So what is saturation? Hemoglobin has 4 binding sites. So if all of them are taken by, regardless of the chemical, it could be carbon dioxide, it could be even carbon monoxide, which is dangerous, but it doesn't matter. If all seats, it's like you're going on the bus and there's like only 4 seats and all 4 seats are taking. So it's completely saturated. Remember we discussed fatty acids, right? Hydrogen on this side, carbon on this side, hydrogen on this side, carbon on this side. This is essential carbon. Carbon has 4 possible attachment sites. So all of these attachment sites are saturated. That's what the saturation means. If this one would be empty, then it's unsaturated fatty acids. Is saturation good or bad? It depends, right? If you want to deliver a lot of oxygen to the tissues, yes, it's great just because you're breathing the most that you can, right? But what if, right? The temperature is gonna increase. So let's say that's the normal arc, right? And we're going to the right, so that will lead to increase of a temperature within the body, right? So when the temperature is increasing within the body, the affinity of the oxygen to hemoglobin drops. When the temperature decreases, let's say on this scale, right, we're here, so let's say that's a certain number, and here the temperature decreases. The affinity of oxygen to hemoglobin increases. It means that oxygen would not want to be released from the hemoglobin molecule. When the temperature increases, the affinity decreases. When the temperature decreases, the affinity increases. It means that if you are in a hot environment and you need more oxygen as the organism, your hemoglobin will release more oxygen into the tissue, which is a good thing. If you are in a cold environment, the affinity of oxygen to hemoglobin increases. It means that you will release less of oxygen into the tissue. You may die. The oxygen within the circulation, but not in the tissue, right? You want to release oxygen into the cell, tissue, and the cell, right? So we're going into the cellular component here. So if temperature increases, that leads to affinity of oxygen to hemoglobin decreases. If temperature decreases, affinity of oxygen to hemoglobin increases. Now let's bring in conversation increase of carbon dioxide. If there's a buildup of carbon dioxide within the system, so that becomes a toxic environment, right? Then the affinity of oxygen to hemoglobin also changes. So if you have a toxic environment, increase of carbon dioxide that your body wants to get rid of, right? So if, again, here's a scale, right? Let's say here. So if there's increase of carbon dioxide, then affinity of oxygen to hemoglobin will also decrease. So if you are in a toxic environment and the toxins increase in your system, and if carbon dioxide is increased, then affinity of oxygen to hemoglobin will decrease. It means that you will release more oxygen into the tissue. So more O2 into a tissue. Same thing is here. More oxygen would get into the tissue. It would not be attached. It would not be binded. We can actually discuss what's going to happen if there's a lower carbon dioxide, but that would be the opposite of this pathway. So if we are in a hot environment, we will detach oxygen and will bring it more into the tissues. If we are in toxic environment, there's also less affinity of oxygen to hemoglobin, so we get it more into the tissue. So this is about a hemoglobin affinity and saturation of what? Of hemoglobin to oxygen.